Welcome to this exploration of a technology that is fundamentally changing how we make, create, and imagine. For centuries, manufacturing has been a subtractive process. We start with a block of material, wood, stone, or metal, and cut, carve, or drill it away to reveal the final object. But what if we could do the opposite? What if we could build an object from the ground up, one tiny layer at a time, turning a digital file directly into a physical thing? This is the revolutionary idea behind 3D printing, or additive manufacturing. It's a technology that is moving from niche prototyping labs to our desktops, factories, and even operating rooms. Let's build up the story of this incredible invention. The story of 3D printing begins in the early 1980s. In 1983, an engineer named Chuck Hull was working for a company that used UV light to cure thin plastic coatings onto tabletops. He had an idea. What if he could use that same UV light to draw on the surface of a liquid photopolymer, hardening it, and then build up an object layer by painstaking layer? Working late at night in a small lab, he tested his theory. He programmed a machine to draw a cross-section of a small cup, hardening the liquid resin with a UV beam. Then he lowered a platform, recoated the surface with fresh resin, and drew the next layer. After thousands of repetitions, a physical object emerged from the liquid. The world's first 3D printed part, a small, black eye wash cup, was born. Hull patented this process, which he called stereolithography, in 1984 and co-founded the company 3D Systems. In 1988, they released the first commercial 3D printer, the SLA-1. A revolution had begun. While Chuck Hull's SLA was the first, other methods of 3D printing soon followed. Today, there are three main technologies. 1. Stereolithography. This is the original method. It uses a UV laser to selectively cure and harden a liquid photopolymer resin in a vat, building the object layer by layer. It's known for producing smooth, high-detail parts. 2. Fused deposition modeling. This is the most common and recognizable type of 3D printing. It works like a robotic hot glue gun. A spool of plastic filament is melted and extruded through a nozzle, which draws each layer of the object. It's affordable, fast, and the basis for most consumer and desktop 3D printers. 3. Selective laser sintering. This method uses a high-powered laser to fuse or sinter together small particles of a powdered material, typically plastic, metal, or ceramic. After each layer is fused, a roller spreads a new layer of powder on top. It's incredibly powerful for creating strong, complex industrial parts. For its first 2 decades, 3D printing was an expensive industrial technology, locked away in corporate R&D labs. That all changed in the mid-2000s thanks to the RepRap project. In 2005, Dr. Adrian Bowyer, a professor at the University of Bath in the UK, launched an open-source initiative with a radical goal: to create a 3D printer that could print its own parts. The idea was to create a self-replicating machine that would drive down costs and democratize the technology. The project was a phenomenal success. As people around the world built their own printers and improved upon the open-source designs, the cost of FDM printing plummeted. This grassroots movement gave rise to a vibrant community of makers and hobbyists, and spawned companies like MakerBot, turning the 3D printer into a desktop appliance. The impact of 3D printing has been widespread and profound. Initially, its greatest value was in rapid prototyping. Designers and engineers could now print a physical prototype of a new part in a matter of hours instead of weeks, dramatically accelerating the innovation cycle. But its uses have exploded far beyond that. In manufacturing, companies are 3D printing everything from lightweight jet engine parts to complex factory jigs. In medicine, doctors are creating custom surgical guides, patient-specific implants, and even 3D printed prosthetic limbs for a fraction of the traditional cost. It's enabling on-demand manufacturing, where a spare part can be printed in a local shop or even on a naval ship at sea, rather than being stored in a warehouse. It's also being used to create everything from 3D printed houses to customized jewelry and intricate works of art. 3D printing represents a fundamental shift in how we think about making. It moves us from a world of mass production to one of mass customization. The ability to turn a digital design into a physical object on demand anywhere in the world is a powerful paradigm shift. We are still in the early days of this technology, but as materials get stronger, printers get faster, and costs continue to fall, the possibilities are nearly limitless. From its origins in a quiet lab, 3D printing has placed the power of creation into the hands of the many. The future isn't just digital. It's a future that you can hold in your hand, printed one layer at a time.